For this video, we are going to be discussing the converse of the Pythagorean theorem. So first off, let's just revisit the Pythagorean theorem. Pythagorean theorem is one of the most famous geometric theorems, and it says that if I'm given a right triangle, then the sum of the two shorter sides, if I square them, the sum of the squares of the two shorter sides is equal to the square of the longest side. And we call the two shorter sides our legs, and our longest side the hypotenuse. And it's normally shown as this equation down here, a squared plus b squared equals c squared. So you've probably seen this before. It is one of the most famous postulates in geometry, or theorems in geometry. But one thing you probably have not seen is the converse of this. So the converse says, if the sum of the squares of two of the shorter sides of a triangle equals the square of the longest side, then the triangle is a right triangle. All right, so we're saying, instead of saying, well, we know it's a right triangle, so a squared plus b squared equals c squared, we're saying that if a squared plus b squared equals c squared, then we've got a right triangle. And this converse has some other implications that are important. And that is that I can use the relationship between the side lengths to determine what type of triangle I'm dealing with. So the way this works is, we know that if a squared plus b squared equals c squared, then I'm dealing with a right triangle, and I've got a right angle here. But if a squared plus b squared is greater than c squared, then I'm dealing with an acute triangle, and this is an acute angle here. So if a squared plus b squared is greater than c squared, I've got an acute triangle. Similarly, if a squared plus b squared is less than c squared, then I end up with an obtuse triangle, and this is an obtuse angle instead of a right angle. So if the square of my hypotenuse is bigger than the sum of the squares of my legs, it's obtuse. If the square of the hypotenuse is less than the sum of the squares of the legs, then it's acute. And if this square of the hypotenuse is equal to the sum of the squares of the legs, then it's a right triangle. And we're going to use this information to find some missing side lengths and also to determine what type of triangles we're dealing with. So, example 1 says, in triangle ABC, AB is equal to 9, BC is equal to 13, and AC is equal to 18. Is ABC acute, right, or obtuse? So what we need to do here is we need to take our two shorter sides, AB and BC, we're going to square them and add them together. And we're going to compare what we get for that to what happens when we square AC. And if AB squared plus BC squared is greater than AC squared, then I know I'm dealing with an acute triangle. If AB squared plus BC squared equals AC squared, then I know I'm dealing with a right triangle. And if AB squared plus BC squared is less than AC squared, then I know I'm dealing with an obtuse triangle. So let's see what we get. So I'm going to simply square my numbers here. 9 squared is 81, 13 squared is 169, and 18 squared is 324. Add these two together and I get 250. Well, 250 is less than 324, so I know that I am dealing with an obtuse triangle. Because a squared plus b squared is less than c squared, I know that the triangle I'm dealing with is obtuse. That's all we have to do. All right, our second example is a coordinate example. So triangle MNP is made of points M at 4, 5, N at 3, -4, and P at 7, 0. Once again, I want to know, is the triangle acute, obtuse, or right? Well, in order to do this, first thing I've got to do is find all of my side lengths. So we know MN is at 4, 5, and M is at 4, 5, and N is at 3, -4. So putting them into the distance formula, I plug them in and work it out, and I end up with the square root of 82. Plugging MP into the distance formula, I end up with square root of 34. And plugging NP into the distance formula, I end up with square root of 32, which is equal to 4 square root of 2. Okay, so I got to find my two shortest sides. That would be MP at square root of 34 and NP at 4 square root of 2. So I'm going to square them and add them together. So 4 squared, or 4 square root of 2 squared plus square root of 34 squared, that gives me 32 plus 34, which is 66. And the square root of 82 squared is just, well, 82. So once again, I see that my C, so if I call these A, B, and C, C is greater than, C squared is greater than A squared plus B squared. So once again, I'm dealing with an obtuse triangle. Really, that's all there is to it. Using the converse of the Pythagorean theorem and this set of relationships here, I can determine whether a triangle is acute, obtuse, or right.